Here we go. Reviewing last week, vertical, horizontal asymptotes. That's like everything you have to know here. If you know that, the rest of it is super easy. So vertical asymptote comes from my denominator. It comes from what can x not be. So basically what makes my denominator 0. And then in this case, that would be x cannot be -1. And since I'm writing it as a vertical asymptote, I'm going to say x equals -1. And then I go to my graph and I put a little dashed line going down. Boom, boom, boom. And it looks like this. I should go down further. There we go. Okay, horizontal. I look at degrees. So I am looking at the exponent for the x's. Do I have any x's on top? No. Do I have an x on the bottom? Yes. What's the degree of the bottom? 1. So I have what is considered the case small divided by big, which means that y equals 0. So we go ahead and we take a dashed line and go straight across at 0. How many of you have a dog? How many of you have been chased by a dog that's been behind the fence? Okay, enough of us. Now, when a dog is chasing something by a fence, does it like start by the fence, then run away from the fence, then run back to the fence, and then shoot down the line, or what does it do? It just gets right up next to the fence, and it runs all the way down, chasing whatever's there. Now, when it's doing that, does it ever run into the fence? I hope not, otherwise that'd be like funny in some videos. But it just runs along the fence and chases as long as it can. If you're on the corner and you're going, the dog's chasing you, you go around the corner, the dog comes around the corner too and keeps on chasing you. All right? So when we test on this, I will be playing Who Let the Dogs Out, because that's literally the whole point of this unit, is where's the dog going? So we're going to find out where the dog started, and then after that, we know where the dog is, because the dog follows our fence, and our fences are placed right here. So once you know the fence, and you know one point, that's all you got to do. You know where the dog's running. Let's pick. I choose a point to the left and to the right of my vertical asymptote. So I'm going to start to the left. Choose something over here. Do not choose -10. Choose something close over here. What do you want to look at? -2. I like how you're so engaged and you're like,
So engaged.
all right. So we go to our little table down here, and I put a -2 right there. And I plug it in my function. And my function was, is it 2 and then x plus 1 divided by? Yeah. So I got 2 divided by x, lied, -2 plus 1. What's that equal? -2. All right. So I get 2 divided by -1, or -2. So let's plot that point. -2, -2. Well, guess what, folks? You hear that? That dog is barking, and it's running. So I just start up here, and I'm going to do this in green. I start up here, I curve through my dot, and I go down. That dog is running, and it just keeps on running. And so the entire left side of the graph is done. 1 point. That's all we needed for that side. Now we got to find the other side. If you ever have 0 as an option, you take 0. Because if I have to find my y-intercept, which is up here, I need to plug 0 anyways. So I might as well use that as one of my points. So let's go ahead and do that. Plug 0 in, and you give me the number. And what do you get when you plug in 0? +2. You get 1 on the denominator, and then we go 2 divided by 1, and we get that 2. So guess what, folks? You open the door, and that dog goes running. So it starts up here by one asymptote and goes along that fence. Griff, it's chasing you. It's running over by you. I don't know. The fence is pretty good though. It won't be able to get you. That's pretty much it. We got to do, these other questions on the side, but there's really not much else to it. So x-intercept, do I ever touch the x-axis? No. So you just say none. Do not say no. Because if you say no, I will just take that as you had a little attitude that day and just decided not to answer the question. Do I really think that's what you're doing? Not necessarily, but I'm not going to read your mind. I'm going to read your work. So there you go. So none or does not exist. Y-intercept, what is it? 0, 2. Nice. Domain. There's different ways of writing this. I like the lazy way of writing this. So I write it like this. All real numbers except x cannot equal -1. Guess what that is? That's your vertical asymptote. All I'm saying is x cannot exist where x cannot exist. It's kind of redundant, but we say x does not exist where your vertical asymptote is. Then I go to my range, and I write all real numbers. Range deals with what? X or y? Y. And y cannot be 0, which is your horizontal asymptote. Now, the other way of writing it, which is on the answer key over there, and there's 2 frames of thought on this. I think this is easier, but I do have to remember x and y. The other thought is you could write this in interval notation, not have to remember x and y, and it would look not like this top part, but like this down here. So I could write my domain as this, -infinity to -1, union -1 to infinity. Basically, this says x can't be -1, which is what we said right there. If you would prefer to write your answers like this, go for it. Okay? I think that's quicker and easier. If you like this better, though, do it. No difference. Questions? All right, end behavior. So now we're going to picture that this dog is running some elevation here a little bit, okay? So as this dog runs to the window, as it's running to the right, that's what this is saying, infinity is to the right, what height is it getting closer and closer and closer to? 0. So we're going to put 0 right here. As I approach, or as I go to the left, as I go to the wall over there, today's all about the window and the wall, you got to look going to the left. Where is it getting closer to? What height? 0. So I put a 0 there. I'm going to slide on down. This is the new thing. I'll put quotes on it because you've actually kind of been looking at it and probably thinking this yourself. This little minus sign in the upper right corner of that -1 is just saying as I approach from the left. This is saying as I approach from the right when it has a plus sign. Now, I'll point something else out in just a moment too, but we're going to make a connection between these two and hopefully kind of help you out. Now, when I look at my graph here, I look at my vertical asymptote, and I'm looking at this from the left. So I go to my vertical asymptote, I jump to the left, where's my function? It's right here, and I go back to it. So I start going down, it's like a boomerang. Where's it going? Down. What do we call down? Approaching. What height is it approaching if it's going down? -infinity. So we put -infinity there. As I approach from the right, I go back to my grid. I go back to my vertical asymptote. I go to the right of it, and then I boomerang back to it. So I'm on my function. Where am I going? Infinity. I'm going up, right? So we go to infinity. Now, this is the connection that I kind of want you to make. Here, I'm given infinities. What am I going to? A number. Pretty much all the time. When I'm looking here, I'm given a number, and I'm going to infinities. That pretty much always happens, okay? So you should be thinking, I need to, if I'm given infinity, find a number. If I'm given a number, find infinity. Where is it going? Up, down, whatever. Does that make sense? Questions? Maybe we should name the dog. I mean, this dog's doing a lot of running for us. What do we want to call the dog? Trixie? I'm going off your shirt. Trix. Yeah, why not? All right. Hopefully, I don't know. Do we want to get chased by a Chihuahua or like a, I don't know.
Chihuahuas are scary though.
Couldn't say that because it's a video, but I'll say it. They're about the size of a football. Okay. I'm just kidding. I don't punt dogs, to clarify. I have a dog. We take care of our dog. Talk about a needy dog. Our dog is needy. Okay, next one here. Vertical asymptote. What is it? X equals 3. Good, thank you. Horizontal or slant. What degree is the top? 1. What degree is the bottom? 1. So we got 1 over 1 or same. So I am looking at 2x divided by x, which is just y equals 2. Let's graph those two things. I don't even know what I just wrote down anymore. 3 and 2. Okay, left, right. Pick 2 points. What do we want to choose on the left? 0 it is. Choose 0. What do we want on the right? 4 it is. Find those two. Plug 0 and plug 4 into both of those. I'll get rid of that. So I'm showing one of them, not both of them, because you can do the other one. What's 0? 0. What's 4? 8. Good. So we got 0, 0. We have 4, 8. And you let Trixie out the door and boom! That doggo is flying. X-intercept, Y-intercept, what is it? 0, 0. Both of them. Domain range, all real numbers, with the exception of x cannot equal and y cannot equal what 2 numbers? And. As we shoot off to the window over here as we're going to the right, what number am I getting really close to? I don't know. What height am I getting really close to? Why 2? That's the dashed line. Yeah, basically whatever your horizontal asymptote is, that's really what you're going to be looking at. So I'm getting really close to this dashed line, which is at a height of 2. And then I look at the next piece as I go to the left, as I go to the wall. What are we getting really close to again? 2 again. Yeah. If I look at negative, or if I look at positive 3, my vertical asymptote, if I look at it from the left, where's it going? Negative infinity. And as I look at it from the right, where's it going? If I'm at the right, where's it going? I go back towards it, and it's going positive infinity. So remember, when you're looking at that, if it has the little minus sign, I go to my asymptote, I go to the left, and then I come right back to it, and I just see which direction I'm going. It's either going to be up or down. Questions? Lane, how long have you been eating that jerky? You're a brave guy. Actually, Grant might be a brave guy for sitting next to you. Well, let me just say, so I made a bunch of jerky from a deer from last year, and our little guy really loved it. He was down in like pound for pounds of it, and we're just like watching him eat. And it's like, okay, I didn't think he would like that, but he really does, and he's just eating it like crazy. But I can tell you after a little bit, there was like a little cloud sitting in there. Nobody wanted to hold him. That was stinky. So, just saying, Lane. All right. That clock's ticking. You see Lane later today. You watch out. I'm sorry, Lane. I guess I am. Hey, it's good protein for you. I will say that. All right, vertical, horizontal, asymptote. Get going on them. See if you can find 2 vertical and 1 horizontal. Small is big, big or small. I'll tell you just. Actually, 0. There's no axis. So it's going to be small or big. Yep. All right, so my vertical are going to be -3 and 2. So let's put those dashed pieces in right away. What is my horizontal or slant going to be? What degree is the top? 0. What about the bottom? Okay, so we got small over big. So I'm looking at y equals 0. Let's choose a point furthest on the left. What do we want to use? -4. All right, plug -4 in, see what you get. I will also show this one on the board just to remind you of order of operations to make sure you get this one right. After that, it's all on you. you should get 1/6 from that. I don't really actually care what the fraction is. I really care, is it positive or negative? Is it above my horizontal asymptote or is it below? And in this case, it's above. So we're going to put that dot down. It's going to be like right here. You guys hear that noise? That dog is just ready to run. We let it out the door and boom. Gone. Cruising. You gotta let the dog out. Should have really worn my slides today. Really let the dogs out. Got a few cringeworthy laughs, but it was worth it. All right. Okay, next we're gonna just completely skip the middle. You know why? You don't want to deal with the middle. So we're gonna skip the middle for a moment. We're gonna go to the right. What do we want to do? 3? All right, 3 it is. Plug it in. Plug in 3. See what you get. When you plug 3 in, what do you get? 1/6. So it's going to be right back up here. That dog's cruising again. Lots of fence to run. All right, so I'm going to write something in the middle. Don't want you to write it down. The middle is, well, let's just say you never quite know. So the middle could look something like this. It could look something like this. Or they could just say, you know that dashed line that we can't cross? Screw that, I do what I want. And it could actually go like this. Or it could go like this. And that reaction right there. Right along, just like, died a little bit. Really, really, really. We will get into more of that later on another day. But so you cannot just do 1 point because 1 point doesn't tell you. In fact, you can't even just do 2 points because it could start coming up here, start increasing, and then fly back down. Because maybe there was a squirrel down there and the dog just wanted to go. I don't know. But regardless, you need 3 points. Okay? So you got to have 3 points to figure this out. And the further along we get, you might be able to get away with less. But let's do this. Half the room, why don't you plug in -2? So, Annabelle, to the wall, you're plugging in -2. Everyone else, you are plugging in 0, and I'll just plug in 1 and I'll give you that point. Okay? So I'll give you 1, and then that way we have our 3 points. So we know are our dots increasing, or do they turn back down, or what's going on? It's just you gotta choose the corresponding one. Yep. All right, -2 people. What'd you get? What? Close. What'd we get? All right, we'll come back to you. 0. What'd we get? What'd we get? All right. What number is bigger? And do not answer right away. think about this. Okay, please don't get this wrong. I might shed a tear. Which number is closer to 0? Is negative 1/6 closer to 0, or is negative 1/4? Negative 1/6 is closer to 0. Okay, so this is what's happening in our picture. I'm going to exaggerate here a little bit. You notice these are the only points that I did not graph right away. And I didn't graph them because I don't want your picture to dictate where the points go. I want the actual numbers, and I need us to be thinking which one's closer to 0. So what happens is it goes negative 1/4. So I'm exaggerating, and then here it's up here, and then it's back down. So it's safe to say that we're looking at something like this. It is not a parabola, as the last class called it. It's a wannabe parabola, okay? You just couldn't get the symmetry thing down, and maybe some other stuff was going on. But it is not a parabola. So we got that. That's what our picture is. Not bad at all until you get to the part where you got to deal with them. Okay? Questions? Domain, range, what are they? What? X can't be what? Negative 3 or 2. Y can't be 0. Okay. Let's talk about... I'm skipping the intercepts. Not too worried about those. These pieces right here. So as I go to negative 3 from the left of negative 3, where does it go as it gets closer to negative 3? Is it going up or down? Up. So that means we are going to positive infinity. As we approach from the right, where's it going? Down. So I'm going to be at negative infinity. Answer these two right here. No, Grant, I didn't think we were going to be practicing today. I thought it was going to rain all day, but that looks pretty good outside. I feel that sometimes. All right, what's our two answers there? As you approach 2 from the left, where is it going? Is it going up or down? Down. So that would be negative infinity. As we approach it from the right, where is it going? Up. Notice these are kind of alternating here a little bit, so just food for thought. Questions about anything?
How you get them last?
These two?
Yeah.
So 2 with the negative up there is saying from the left. So I go to my vertical asymptote, I go to the left of it, I get on this function and I trace it. As I get closer to that vertical asymptote, where's it going? Down. So that's negative infinity. Then when it has the 2 and the plus sign, it says the right. So I go back to my vertical asymptote, I go to the right, I grab a hold of this function and I trace back. Where's it going? Up. So that's how that works out. Any other questions? Last one. Vertical asymptote, I'm going to tell you, it is just x equals 2. What case is this? Big over small, which means you have to synthetic division. You you can look to factor first, because sometimes you will be, able to do that.
Great. What? Is it a 2 or a -2?
It's your vertical asymptote. 2. Yep. See, everybody hated that video, but everybody remembers.
I like that video.
Yeah. Not everybody hated that video.
Remember your flowers.
Yes. Then you gotta draw him too, because you nailed it.
That was fun.
It was.
I like that he took it seriously. I thought he was very serious about it.
Oh, he was very genuine.
Yeah, he was
100%.
he didn't he was joking about that.
Yeah.
Can't you wait? I thought you could just take the amount of X's that there's 1, 2.
So you divide only when they are the same, not kilo. So you have to do synthetic division. Whenever this is degree 2 over degree 1. So it's big over small. So you do synthetic division. And you gotta drop it like a top. Now, do I want a number there? Yeah, I kind of do actually. If that's 0, it means that something up here should have factored and canceled out, and we would have been left with something that you will learn about on Wednesday, which is a hole in your graph. And it's basically, you have your graph, and then all of a sudden, it just disappears, and then it appears again and keeps going. Oh, the joys! Don't you wish this was your first unit of the year?
Yeah.
You all would have been staring at me like this. And then a couple of you would have been like this. And then there would have been a few storms, but not a lot, so it's all right. So my not horizontal, slant in this case, is going to be y equals 1x minus 4. Now, I'm not going to walk around the room because I don't want to know how many of you forgot how to graph a line, but I'm going to give you the opportunity to graph that line, and then I'll talk about it. Walked around in the other class, and I'm not going to lie, that got painful, so I'm not going to do it this time. Touche. I deserve that after the beef jerky comment. Y-intercept is -4, so I put a dot right there. My slope is 1, which means I'm going up 1 to the right 1 repeatedly. So I'll put some dots in to do that. You could even do dashed lines, so then you don't have to go back. Yeah, that is our slant asymptote. They actually don't complicate, not complement. They don't complicate the problem that much. You still choose a point to the left and a point to the right. The only difference is that when I choose points, I would like to know the y-coordinate of my slant asymptote. So I'm going to choose 0 as one of my points, and that's because I know the height here is -4. So if I get -3.75, which I'm not going to get, I can compare it and say, okay, that's above my slant or it's below my slant. That's really what you're looking for. When I look for another point, I could choose -3 because that's a height of -1, or I could choose -4, which is what I'm going to choose because 0 is easy to compare to as a height. So you got to plug it in. So let's plug in 0 together. I get 0 squared minus 6 times 0 plus 1 divided by 0 minus 2. Don't grab a calculator. What's my answer? -1/2. -1/2. Good. So I look at 0. That's right about here. You hear that dog scratching on the door? Open that door up. Let that dog go. There it is. Gone. To infinity and beyond. Other side, plug in the 4, see what you get. Fractions are fine, decimals are fine, doesn't really matter. You just gotta get a number. What's the number? Negative. What'd you get, Griff?
It doesn't feel right.
It is a decimal or a fraction.
It's not right.
Okay.
Well, I got a fraction.
What'd you get?
I'm not telling you.
Oh. Does it have a 2 in the fraction? Oh my god. Alright, somebody throw a number out there.
5.
I got 41 over -6. Is that what y'all got? I'm not sure.
Alright.
See, I'm not the only one that's silly.
Here's our function. We take 4, we plug it in. What's 4 squared?
16 plus 24.
Minus 24.
But you gotta wait. What?
Wait,
It's -4
It's -4.
times -6.
No, it's not.
Son.
It's oh,
Son.
that's my bad. That's my bad. Just 4. We're gonna go back and plug
Oh,
4 in.
come on.
So, Griff, you are right.
Yeah.
You would be right with that answer. We're plugging 4 in. We need a point to the left and to the right. Yeah, that's my bad. I'll take that thumbs down. At least there's no tomatoes being thrown. Yet. Hey, I wouldn't complain. Yeah, I did set you up to fail on that one. Oops. I'll give you a free finals question for that. What room are we in right now?
222.
222. Is it 222?
Yeah, it is 222.
Oh, good God.
Just might be worth knowing.
how many people just
This is
forget that you
which
have
one is
that?
the MRC? Oh, it's MRC.
2,
Yeah, I know that.
3.
1.
I would maybe find out that last digit before your final.
No,
Okay,
MRC.
what do we get? What do we actually get this time?
Yeah.
I'll see that. I don't know.
Yes, negative 3.5. Okay. Negative 3.5. See, there's a plus sign there. It's been there the whole time. Yes,
I got that on camera.
I know. Negative 3.5. So we're sitting right somewhere right about there. So again, we let our dog go running and now the only thing we're going to look at on this problem is the x-intercept, and I'll help you with that. We're not going to actually find it completely. I want to give you some time to do the homework. But this is how you look at it. When I'm looking for an x-intercept, and we're going to have more practice on this in the next few days, is I actually write this out. 0 equals x squared minus 6x plus 1. Where's my denominator? I got rid of it. Why can't I just get rid of my denominator? Again, this is x-intercept. This is why we can get rid of it. So my denominator is x minus 2, correct? I'm actually double checking because you've seen my track record. Now, well, if I times this by x minus 2, you did this in your last chapter, you could cross this off, right? But then I have to do that to the other side. What is 0 times x minus 2? Still 0. So when I'm finding an x-intercept, I go 0 equals my numerator, and I could care less what the denominator is. Now for this one, you would have to do the quadratic formula, and I would rather have you do two things. One, make sure that you have 14.1 and 14.2 done. If you don't, do those, because your quiz is basically, I just ripped out a sheet of your homework and gave it to you. It's either 14.1 or 14.2. It's something just like that. So get that done, check your answers, make sure you can do it. And then 2, start on 14.3, okay? You want to have 14.3 done before 14.4. Otherwise, things kind of blur together. Like plus signs and minus signs, like those sort of things. And then we all get messed up. Lane stretching right now. All right.
Somebody's got it.
Fair enough. Good luck.